Now we move to the last topic of this lesson, and it is also the last topic of this chapter. But before I continue, I want to tell you, first of all, thank you for all the subscribers. It means a lot. And thank you for all the love, the wishes. I greatly appreciate all of you. And if you have not yet subscribed and if you have found these videos helpful, please do subscribe for this channel and do share it with your friends who might find it useful. Now, getting back to the topic, here we have equation of the motion ball. Before we come to this equation, I will give you an instance, real life instance. I'm sure all of you watch football, or at least all of you know about football. And sometimes you might see sorry, no, that's not a proper ball. Okay, let this be a player. He will hit the ball. Over here is the goal post. Okay, imagine he hits it. He won't hit it straight. Obviously, the goalkeeper will catch it. He won't hit it like this. Sometimes he will hit it with an angle and it will incline and go inside. Okay, what I'm trying to say is, if this is the person, he'll hit the ball, it'll incline and then go inside the goal post. You might have watched many videos like this. So what is that? That is the knuckleball effect. It is from the Magnus force. So what happens is, because of the air, when you hit the ball, this will start rotating, tilting, and then that angle forms. So now we will study about that, little bit basics of it. Not in detail, but just that you must remember this formula when it's a knuckleball equation. The acceleration x double dash t is equal to negative 10 sine 4 omega t plus theta naught. We will see this in detail now in this problem. Over here, the spinning rate, that is the omega, the spinning rate, 2 radian per second it spins, and the theta naught is 0. Find the equation for the lateral motion of the knuckleball and graph it for time from 0 seconds to 0.68 seconds. Now, over here, we need to know this formula. This is the Magnus force equation. Substitute all that is known. Here, minus 10 sine 4 omega is 2. Substitute it, and theta naught is 0. Now, this will be equivalent to minus 10 sine 80. Okay. Now, we need to find the velocity, that is, integrate this. What happens when you integrate it? Now, if you're wondering how you get this, can you directly integrate sine? Okay, sine is negative cos. Fine. But how do you do it? It is 80. You have to do u substitution. So now I want you all to start u substitution and try to do this. I'll tell you the basic of u substitution over here. It'll be u equals 8t, and then you need to solve it up. Okay, what will be du? It'll be, you need to derive this and so on. You need to solve it. It'll be du is equal to 8 du by dt. Sorry, what is dt? Take this to the other side, it'll come down, so you will have du divided by 8. So that's why it's 1 by 8 over here. Okay, when you solve it, try this u substitution method. You have done this before, so when you solve it, you're going to get this particular answer plus c, constant of acceleration. Now, what is the initial velocity? Okay, before that, now over here it's rearranged. Negative 10 by 8 cos 8t plus c. Negative 10 by 8, sorry, my bad. Over here the negative goes and it becomes positive. So it's 10 by 8 only. And what is 10 by 8? It is 1.25 cos 8t plus c. Now over here, remember, we need to find the c. So let us find what is the initial velocity. It's not given, it's 0. So substitute over here 0 and solve. But remember, don't directly take the answer. Why? C value varies. In the previous videos, in the previous sections, I told you the C value varies when it is trigonometric function. Here we have a trigonometric function, that is sine or cos. What happens? The C value may vary, may change. If it's 0, it may not be 0. You need to substitute. X dash of 0 is 0. Yes. Now put over here in this equation, everywhere 0. So x dash of 0 equals 1.25 cos 8 into 0 plus c. Now 8 into 0 is 0. Cos 0 is how much? 1. You can try it in the calculator. Sine would have made it 0, but this is cos. So 1.25 into 1. Now take this to the other side. It will be minus 1.25. That is C. This is the thing. Now what next? You will have x dash of t equals 1.25 cos 80 minus 1.25. So this is the answer. Then we have x of t, to that is the position. Integrated again. We have done the same thing, right? We are doing it over and over. Now one thing over here, you can simplify it by removing this common out, but don't use it when you're, when you're integrating. You will allow to split it out. But if they have just asked you the velocity or something, this would be the answer. If this is not there in your options, this might be there. Okay. Now integrate this particular equation again. What will you get? Again, u substitution. I hope you know the u substitution. Take this as u and solve it up. And over here cos becomes sine. It will be integration of cos is positive sine 80. Because of u substitution, you'll have 1 by 8. They get you 1.25 t plus c. Now, what is the initial position? 0, not mentioned. So what do? It is x of 0 is equal to 0. Substitute wherever t is there as 0. Now, since it is sine function, everything will become 0. Okay. Sine 0 is 0. Multiply anything with 0 is 0. Over here also minus 0 plus c. This is also 0. Now you will get the position. Sorry, over here. This is the knuckleball equation. That is, this is for the motion. 0.156 sine 80 minus 1.25t. Now, how did we do it? By integrating the acceleration equation. This is a kanun, like a formula. You must by heart this, integrate it with the given values of omega, that is the spinning rate, the theta naught is the angle. Put it over here and then solve it, integrate it. Use substitution for integration, and then you got the final equation. Now, this can be graphed. X of t can be graphed from 0 to 0.6. The graph will be something like this. How do we graph it? Since it's very small numbers, take small values, 0.1. Put over here instead of t as 0.1. How you can do it is, so it will be just very simple. 0.156 into sine 8 into t, that is, let me take 0.1, 0.1, 0.2, 8 into 0.1, multiply minus 1.25 t is 0.1 plus equal to, what is the value you're getting? 0.122. See now here it is about 0.122. Same way, change the value to 0.2. I'll just change it over here, make it 2 and make this to 2. You will get over here. Okay, now is this the correct values? Very good, this happened. Anyways, now is this the correct answers? What is my mistake? I have to change this to radians, guys. I forgot to change it to radian. Now I will get the correct answer. This is the correct answer. Okay, it is close to 0.1. Look, 0.2 is close to 0.29. That is 0.09 or 0.1. Okay, let me take another value, 0.4. It should be somewhere 5. Okay, let me take this. The graph over here, it will be 0.61. Let me check 0.4. If it's draw a straight line, okay, it's not straight enough. It is around that. Okay, it's around 6.1. Okay, make sure always it's in radian mode. Okay, that is, my lines are not accurate, but if your lines are accurate, you will get it. But make sure you are using accurate mode, that is radian, when you're using trigonometric function. We have done that before. So if you do not use radian, you will not get the correct answer. So please make sure about that. Okay, then you can easily get it. Sorry, I have used 0.5 and 0.4. Okay, so please make sure you use it properly. I have done many mistakes. Now 0.5 is over here. It should be 7.4. Let me draw a straight line, and it should be a straight line and something over here. That is about 0.4. Yeah, mine is not very accurate. 0.7, sorry, 0.74. I don't know why I'm missing numbers. Maybe because of the last video and I'm just tired, I guess. Sorry for that. Now, I hope you understand the concept. How you do is take different values of t and check the graph. If this this problem will come in the, as MCQ, you will have the graph. You can easily check the graph in this equation. Just put the x values. Instead of t, you should put x because it's x of t, and then you can check the y values. All are a negative quadrant. The correct graph will give you the correct answer. So this is how you can easily solve it up. Only thing in this is remember this particular formula and then integrate it. We have done this integration many times to find the velocity position. The position is the equation which you have to solve for lateral motion. Okay, and then you can graph it. So that is the end of this lesson and the end of this chapter. Stay tuned for the next chapter. I will be starting to do the explanation videos soon for the next chapter as well. Till then, happy learning and all the best. See you soon, guys.